Hello everyone, what's up people? Welcome back. How y'all doing? Good evening everyone. Long time no see. And by the way, people, belated happy Republic Day. I hope that all of you guys, paid at least a little bit of respect to the country. Yeah. How are you guys doing? How was your Republic Day celebrations? How's everything going? I'm great, Devpita. Thank you for asking. Thank you, Arshad. I'm awesome. How are you guys doing? Good evening, Alina. What's up? Nice haircut. Thank you, Alina. Thank you. Much appreciated. At least you guys saw it. Hi, Dhruva. How are you doing? Hi, Kirti. Long time. What's up? Welcome back. I hope that all of you guys are doing good and taking care of yourself. So, yes, people, today is going to be another day, another amazing chapter we're going to complete today. That is refraction of light at plane surfaces. So we're going to be doing the entire chapter. So without wasting any of your time, let's begin, because there's a lot to cover and there's not much time. There are a lot of derivations to do as well. So I might not have enough time to complete the whole thing. So let's just quickly finish off. My name is Anoop and welcome to the session, people. Let's begin. Alright, refraction of light at plane surfaces in one shot. Let's do it. Now, this is the quote for today, people. Believe that you will succeed and you will. This was said by Dale Carnegie, who's one of the best authors of all times, if you ask me. There are a lot of good books that he's written. So his statement is this: that believe that you will succeed and you will, and that is the first step to success. You have to believe, you have to truly believe that you can actually do it, and that is what is going to make you move on. You'll obviously find a way then to succeed in life, right? Anyways, so that's it, people. These are the topics that we'll be doing today: refraction of light, laws of refraction and refractive index, factors affecting refraction and principle of reversibility, refraction through a prism and factors affecting the angle of deviation, real and apparent depth and critical angle, total internal reflection, and TIR through a prism, that is total internal reflection through a prism. So without wasting any more of your time, let's begin. Before we get started, people, do not forget to hit the like button and also to subscribe to the channel. Yeah, promotion done. Let's begin. Alright, what's refraction? Let's understand, like from the basics, let's understand everything. What is refraction? In the most simplest term, refraction is nothing but when light is traveling from one medium to another, maybe a rarer medium to a denser medium, or denser medium into a rarer medium, the speed of the light would vary because the density, the material's density is different. So the speed, the obstruction offered to light is also a little different. So the speed of light would vary. And because of this change in the speed of light, what happens is the path of the light also changes a little. This change in the direction of a ray of light, or the path of a ray of light, when light is traveling from one medium into another, this is what is called as refraction. Now, one of the best examples is this one. You see this, there is a simple glass tube which is kept inside a cup of water. You can clearly see that the glass tube appears like it's bent, but is it actually bent? No, it's not, but it appears to be bent. So this is what is called as a reflection. The bending of the ray of light, or the change in the direction of ray of light, or the change in the path of light, however you want to say it, but that is what is called as refraction. Now, refraction is a very common phenomenon, especially when you're looking at something that is, let's say there's something underwater and you're looking at it. It appears, like for example, this pencil, which we just saw the same example right now in the case of a rod. So when you put the pencil inside and when you see from the top, see the pencil looks like or appears like it's raised up. So what you're doing is that you're not seeing the actual pencil, no, but what you're seeing is the illusion of the pencil, which is what is called as an image. The illusion that is formed because of refraction, that is what is called as an image. Now here, look at this. So you see this, the ray of light is actually coming from here, but then once it reaches the surface of separation between air and water, what happens is that it changes the direction. The bending of ray of light happens and it falls into your eyes. Now when that ray of light falls into your eyes, what does your eye do? Your eye will try to trace back where the light came from. For example, okay, it's a very simple example. I give this all the time. Now if you're in a room, imagine that every one of you guys is in a room, alright? You guys are in a room and you hear some sound. Now, won't you turn towards towards that direction and see where the sound is coming from? Like, won't you have that curiosity to turn around and see who's making that sound or what is the source of that, so the source of that sound? Like when you're sleeping, you hear a sound, you always know that that is how your brain works. You want to know where it's coming from. So here also it's the exact same thing. Your eye want to know where the light is coming from. So when it traces back that ray of light that appears to be coming from this region, when you trace it back, it appears as though the real light is emerging from this place rather than from here. It appears as though it is coming from here, and this is why images are formed, especially when you talk about refraction. The same goes with even plane mirrors also. You've probably seen that plane mirror, you always see a virtual image. Why? Because your eyes is trying to trace back where the source of that light is, and that is your general curiosity that you have. Now a couple of things that you have to remember is this, guys. When a ray of light is passing from a rarer medium, like for example from air into glass or water, air is the rarer medium and glass or water is the denser medium. So the ray of light that is coming and falling on the surface, that is called as the incident ray, and to the surface, if you were to draw a perpendicular line, that is called as the normal. You guys already know about this, but still, just for all those who have forgotten this is a quick revision for you guys. Now the ray of light that passes through the glass slab, that is called as a refracted ray because it changes the direction, or the bending of ray of light happens. Now when it's traveling from a rarer medium into denser medium, remember this, guys. In a rarer medium, the speed of light is much more faster. It's higher speed, all right? The speed of light is really fast. Like in the case of vacuum, the speed of light is 3 into 10 to the power of 8 meter per second. But if you talk about the speed of light in glass or the speed of light in water, the speed of light is going to be much more lesser than when it's in air or in vacuum. Because why? The density of the medium is higher. So lesser the density, higher would be the speed. Higher the density, lesser would be the speed of light. So because of this reason, when light is traveling from a rarer medium into denser medium, it will always travel towards the normal. If this is the normal, it will move towards the normal. When the ray of light is passing from rarer medium into denser medium, it will move towards the normal. But when it's going from denser medium into the rarer medium, it will move away from the normal. Like in this case, you can clearly see this. So this is the incident ray. Once it reaches the surface of, I don't know why my lines are going all left and right today. It's like going from Bangalore to Pune and all. 1 second, let me just erase this. So you have the incident ray that is coming in straight. Once it reaches the surface of separation, you can see that it goes towards the normal, slightly towards the normal, like not exactly on the normal, but it's towards the normal. And once it reaches the next surface of separation, that is when the ray of light is emerging from glass into air, where glass is the denser medium and air is the rarer medium, it moves away from the normal. You can clearly see that it moves away from the normal. Simple. Right, people? Exactly. That's all. So this ray that is coming out is called as the emergent ray. This is the incident ray, and this is the refracted ray. Simple, right? Okay, now one more thing you have to understand, guys. In a glass slab, not in a prism, in a glass slab, because the surface of separation, both of these surfaces are parallel to each other, the emergent ray that is coming out of the glass slab, is going to be parallel to the incident ray. Now this does not happen in a prism, no, because in a prism the refracting surface is actually inclined. But when the surface of separation is parallel to one another, like in the case of a glass slab, the emergent ray is going to be parallel to the incident ray. So if you extend this original path of light, because light was supposed to go straight, if there was no glass slab, light would have gone in a straight line, because light always travels in a straight line. But because of the glass slab, it slightly changes the path, or the bending of light happening. But the ray of light that is coming out of the glass slab is going to be parallel to the incident ray, right? All of these are simple topics. You already know about it, but again, it's a one-shot revision, so let's quickly do it. All right, one last thing I would like to talk about is this, guys. If the ray of light is passing at the normal, like exactly at 90 degrees, if the ray of light is incidenting exactly at 90 degrees to the surface, that is on the normal, then there will be no deviation whatsoever. The ray of light will pass through straight, undeviated. There will be no deviation whatsoever if the ray of light is incidenting at 90 degrees. At any other angle, you'll be able to see, some sort of refraction you'll be able to see. There'll be some bending of light happening. There'll be some deviation happening. But if the ray of light is incidenting exactly at 90 degrees, then there'll be no the light will get refracted, but there'll be no deviation. There'll be no deviation from the path. The original path itself, it will follow without any sort of deviation. So this is what we've seen so far, guys. Let's just quickly finish up. When light goes from rarer medium to denser medium, it moves towards the normal. When light goes from denser medium into rarer medium, it moves away from the normal. And when the ray of light is hitting normally, that is at 90 degrees to the surface, then there'll be no deviation whatsoever. In other words, it will pass through the glass slab undeviated. All right. Okay. Now that you understand this, people, let's talk about the laws of refraction. What are these laws of refraction? Just like reflection, because everything in nature follows some laws. You have Newton's law of motion, you have laws of reflection. In the same way, you also have laws of refraction also. Now, there are two laws of refraction. The first law, though, you already know. It's the same as the one that you have in your law of reflection. That is, the incident ray, the normal and the refracted ray all lie on the same plane. It will not be outside. So for example, if I insert a paper, let's say I've inserted a paper, the paper here is nothing but the plane. All right. So all of that, the incident ray, the normal and the refracted ray, all should lie on that paper itself. It cannot lie outside the paper. It cannot lie behind the paper. It should be on that paper. When I say paper, it's nothing but the 2D figure, which is nothing but the plane. So all of this should lie on the exact same plane. I don't think there should be. Is that clear? Is there any doubts in this? Yes, there is Menti. Don't worry, there will be Menti. 100%. There is Menti. So chill. Now, did you guys understand this? The first law of refraction is clear. That is the incident ray, the refracted ray, and the normal. They all lie in the same plane. Is there any doubts in this one? If there is any doubt, no, let me know right now. No doubts, no? Awesome. Yes, Ashmi ji. What is this? Long time no see. All right. The next one is quite, this is also called a Snell's law. The second law of refraction is also known as Snell's law. Now, this second law shows the relationship between the incident ray, the refracted ray, or you can say angle of incidence, angle of refraction, and the speed of light in both the mediums. So this is the basic relation. Angle of incidence I divided by angle of refraction R is equal to the speed of light in the first medium to the speed of light in the second medium. That is I. This is the first medium. This is the angle of incidence. This is the angle of refraction. This is the first medium. This is the second medium. So the incident angle divided by the refracted angle, or angle of incidence divided by angle of refraction, is equal to the speed of light in the first medium to the speed of light in the second medium. Now what I'm going to do is, I'm going to take the sine of these two angles. That is, I'm going to put it as sine I by sine R. I'm going to find out the sine of this. So basically what the second law of refraction says is that the ratio of sine of angle of incidence to the sine of angle of refraction is going to be a constant. Now what do I mean by that? See guys, as long as the temperature, as long as the density of the medium, all of that is kept constant, can you guys tell me yes or no that the speed of light in a medium will not change? Yes or no? Do you guys understand it? I mean, are you able to understand the question? That the speed of light will not be affected as long as all the factors are remaining same. Yes or no? The velocity, basically the wavelength of light, the temperature, if everything is kept constant, the speed of light is going to be constant. So that means that this ratio that I have, the speed of light in the first medium to the speed of light in the second medium, for a pair of medium, that is for, let's say, air and glass, or glass and water, whatever it is, whatever the medium is, this is going to be a constant value, because the speed of light will not change as long as all the factors affecting the speed of light is kept constant. The speed of light is going to be same. So if I find the sine of the angle of incidence to the sine of angle of refraction, that is equal to the speed of light in the first medium to the speed of light in the second medium, which is a constant, which is what is called as your refractive index, known as mu. This is what is called as your refractive index, in other words, or index of refraction, how you want to call it. So this refractive index tells you by how much will the ray of light get refracted. Is it going to be more? Is it going to be less? That you can understand by understanding the refractive index of a particular medium. Did you understand this, people? Are you able to understand like what is the relationship? So sine I by sine r is equal to speed of light in the first medium to the speed of light in the second medium, which is nothing but a constant because speed of light does not change like that. It is constant, and that constant is what is called as the refractive index of a particular medium, or called as index of refraction, right? Diffraction, you don't have it right now, Yash. Diffraction you'll study in your 11th and 12th grade, not right now, alright? So this is your second law of refraction, that is sine I by sine r is equal to v1 by v2, where v1 is the speed of light in the first medium to the speed of light in the second medium, and that is nothing but a constant for a pair of medium, and that is what is called as your refractive index. So in terms of statement, like in your exams, what are you supposed to write? Second law of refraction says that the ratio of sine of angle of incidence to the ratio of sine of angle of refraction is constant for a given pair of medium, which is also known as the refractive index, or also known as the Snell's law. This is what is called as Snell's law. It's the exact same thing. It is the exact same thing. Now I want you guys to remember this relationship, people, because we will be doing a lot of derivation based on the exact same law. So make sure you remember all of this. It's super duper important. This is what is called a Snell's law, or the second law of refraction, also known as this ratio, or this constant, is what is called as the refractive index. Now, okay, I hope you understand. Hi Priyam, what's up now? Okay, now there are two types of refractive index. One is absolute refractive index, the other is relative refractive index. Absolute refractive index is nothing but the ratio of speed of light in vacuum to the speed of light in the medium. So that is absolute refractive index, because the speed of light in vacuum does not vary. It is 3 into 10 to the power of 8 meter per second itself in vacuum. Vacuum, there is no change in the speed of light. So let me just write with a different color. So the speed of light in vacuum is going to be 3 into 10 to the power of 8 meter per second itself. So that value already know. We already know that the speed of light in vacuum is 3 into 10 to the power of 8 meter per second. So when you compare the speed of light of in a particular medium to the speed of light in vacuum, that refractive index that you get is what is known as absolute refractive index. So when light travels from vacuum to another medium, the refractive index that is known as is what is called, that you get or you obtain, is what is called as absolute refractive index. In other words, the ratio speed of light in vacuum to the speed of light in the medium. So absolute refractive index is equal to C, which is the speed of light in vacuum, divided by V, which is the speed of light in the particular medium. Now the medium could be anything. It could be air, glass, whatever. It does not, it could be air, glass, water, whatever it is, it does not matter. But that is what is called as your absolute refractive index. So refractive index of glass is equal to speed of light in vacuum divided by the speed of light in glass. Now again, you can represent refractive index as mu, or you can also represent it as n, whichever way you are comfortable doing, you can do it that way. So either you can represent it as mu, which is nothing but this, or you can also represent it as n. That is what is called as absolute refractive index. That's it. All right. So now, the next thing I'm going to talk about is nothing but the effect of speed of light in terms of wavelength and frequency due to refraction of light. Now, the thing is this, guys. If the speed of light is more, then the refraction is going to be less. Right? The speed of light is more, then the refraction is going to be less, because the deviation is going to be less. So this also depends on the wavelength as well. Greater the wavelength, lesser would be the refraction. Greater the wavelength, lesser would be the, so if the wavelength is more, then the refraction is going to be less. Refraction is going to be much more less. In other words, the refractive index is going to be much more lesser. Nu or n will be lower if the wavelength is more. So for example, if you talk about red light compared to violet light, red light will have the least refractive index in comparison to violet light, because violet has greater, it has very less wavelengths, so the refraction is going to be more, so the refractive index is also going to be greater. The next thing I'm going to talk about is absolute refractive index. So I hope you understood this so far, guys, because I'm going a little fast, because last time also I could not complete the entire thing in 1 hour. So I'm going to go a little fast because there's a lot to do. So here is the next topic, which is nothing but the next one is nothing but relative refractive index. So this is the same thing I just told you. The refractive index of medium is equal to speed of light in vacuum divided by the speed of light in the medium. So greater the speed of light in the medium, lesser would be the refractive index. Lesser the speed of light in the medium, greater would be the refractive index, because it's indirectly proportional. So greater the speed of light, lesser would be the refractive index. Lesser is the speed of light, greater would be the refractive index as well. Alright, the next one is relative refractive index. Don't worry, I'll be taking Menti. Right after this, I'll be going into the Mentimeter itself. Just this one topic, and then we'll get into the Mentimeter. Relative refractive index. Relative refractive index is nothing but the ratio of speed of light in one medium with respect to the speed of light in another medium. Not vacuum. Let's say that the light is going, a ray of light is traveling from air into glass or from glass into water. So the speed of light in glass divided by the speed of light in water would give you the relative refractive index. So relative refractive index is basically when you're comparing two different mediums, not to vacuum, but two different mediums, air and water, glass or water, whatever it is. Whatever the medium is, that is what is called as your relative refractive index, because it's relative. In other words, it's in comparison with something else. So this is how you find out. For example, if you want to find out the refractive index of water with respect to air. So this symbols, this W by A, N, the subscript WA shows that the refractive index of water with respect to air is the refractive index of water divided by the refractive index of air. Now, how do you find out the refractive index of water or air? By finding out the absolute refractive index. We just saw that. So absolute refractive index of water will be what? Speed of light in vacuum divided by the speed of light in water. The same goes with the absolute refractive index of air as well. So absolute refractive index of air is speed of light in vacuum divided by the speed of light in air. So if you find that out, if you divide the ratio, you will get it as velocity of light or the speed of light in air divided by the speed of light in water. Now, remember this, guys. Remember this. Refractive index of water with respect to air. Water with respect to air is speed of light in air divided by speed of light in water. Not water by air, but air by water. Now, this is one thing that majority of you guys go wrong in. So make sure that you remember this relationship, that the speed of light, if I want to, okay, for example, I want to say that I want to find out the refractive index of the second medium with respect to the first medium, then it will be the speed of light in the first medium divided by the speed of light in the second medium. All right, this is also the exact same thing. Just like how we wrote over here, it is N21. I can also write it as N21, like the subscript on the left hand side. It's also the same thing. That means the refractive index of the second medium with respect to the first medium is equal to the velocity of light or the speed of light in this first medium divided by the speed of light in the second medium. It's very, very, very important, guys. Very important that you remember this. This relationship is going to save your life. Literally, it's going to save your life, because there'll be a lot of questions asked from this one single relationship. Remember this. So refractive index of second with respect to 1 is equal to speed of light in the first medium divided by the speed of light in the second medium. So if the refractive index, or you see that the ratio, if the speed of light in the first medium is greater than the second medium, then you can say that medium 2 is much more denser. And if it's the other way around, if the speed of light in the second medium is faster than the speed of light in this first medium, then you can say that 1 is a rarer medium. Just like that, you compare it and you can tell which is rarer and which is denser. And if in case you find out the ratio to be greater than 1, then you can say that medium 2 is denser. If it is less than 1, then you can say that medium 2 is rarer. So that's how you find out the relationship. Alright people, let's get into the quiz time now. All of you guys are like spamming, sir, Menti. Let's get into the Menti now. 8 questions I have for you guys, so quickly join the Mentimeter, people. All you have to do is go to www.menti.com and enter the code 2529789. That is the code for today. Quickly join it and let's go. Yeah, there is Menti. Alright. I know. So when work power energy second part will come out, Priya, I'll be releasing it this week. I could not get time last week because I had lots of sessions last week. Like every day I had like 5 to 6 sessions. That's why we'll be doing it this week. I did not get time at all to record. So this week I'll send it out, right? This is a small part. The last portion that is left out. No, I'll do that. Don't worry. All right. Divyaji, not yet. I'll be checking it out today or tomorrow. Yesterday also I was a little busy. So yeah, people, let's go. Sure, Shilpiji, don't worry. This is the Mentimeter. How many messages? My God, all of you guys are like, Menti. You don't want to study. All you guys just want to do Mentimeter. All right, let's go, guys. Let's go. All right. I think everyone's here. If you're not in the Mentimeter, quickly join the Mentimeter, people. All you have to do is www.menti.com and enter the code 2529789. That is the code. So join it. I'll be starting the quiz in 5, 4, 3, 2, 1. First question of the 8 questions. Here's the first one. The refractive indices of two substances A and B are 1.2 and 2 respectively. Light travels faster in which of these medium? Substance A, substance B, speed of light remains the same, or it is moving from a less dense medium to a denser medium. Less denser medium to a denser medium. Go for it, guys. Let's go, let's go, let's go. Oh, Siddhanji, what's up? Long time, long time. A lot of you guys are here, huh? Welcome back. Hi, Mayaji, what's up? How are you doing? Welcome, welcome, welcome. Who's my favorite actor? I like Rowan Atkinson, Mr. Bean. Alright, 26 of you guys were able to give the right answer. That is a good number, people. That is a good start. Absolutely spectacular. Yes, it is going to be of substance A. Why substance A is because of the fact that the refractive index is less, speed of light is going to be more. Refractive index is more, speed of light is going to be less, because n is equal to c by v. So remember that it's indirectly proportional, and hence option number A would be the right answer. So that is the answer to the first question, guys. I think, yeah, we have another question as well. So here is your leaderboard at the end of that first question. 8th grader, oh my god, 8th grader is beating all the 9th and 10th graders. Arey Suryash ji, what's up? Absolutely wonderful. Lijab, high five buddy, high five. Prasoon, high five to you too. Harshal, high five to you too. Thank you guys. Bran the broker, Kwahish, Keshav, Jai Mataji to you too. Then Kritika, class 9th ICSE, Shri and MKS. Beautiful guys, beautiful, beautiful. Congratulations, that is a good competition. Moving on to the second question. Here's another one for you people. If you're not in the quiz, quickly join it, because we have 8 questions and we're already done with 1, which means that you still have a chance to get on the leaderboard. Here's another one. According to the Snell's law, the relation between the angle of incidence and angle of refraction is: the angle of incidence is always equal to the angle of refraction. Angle of incidence is always greater than the angle of refraction. The ratio of sine of angle R to the sine of angle I is equal to the refractive index, or the ratio of sine of angle I to sine of angle R is the refractive index. What is it? 4 more seconds. Is it Ashmish? Arey, no, don't lie now. You to. Arey, awesome people, awesome. I thought a lot of you guys will go with option number C, but you guys are very smart. That was a clear trap laid out for you people. I was 100% sure at least 30% of the class will fall into that trap, but no, only 2 of you guys got it wrong. That is amazing, guys. That is amazing. That shows how carefully you guys are reading the question, and absolutely yes. Remember that your refractive index n is equal to sine I by sine R, not the other way around. It is sine I by sine R. So yes, the right answer is option number C. Is there another question? Yeah, we have another question as well, people. Now this is a problem, so make sure that you have your pens and papers ready with you so you can solve this question as well. But nonetheless, once again, the leaderboards: Suyash is on the top, Prasoon on the second, Harshal on the third. Okay, wait, Prasoon on the top, Keshav was the first to answer, Suyash on the third, Dhruva, call me Dhruvs, alright, Dhruvs, Adarsh, high five to you now, then Harshal, yeah, already high five, Shri, Parleji, Kwahish, and Bran as well. Parleji. G for genius. Alright, moving on to the third question. Here is the third question, people. Take a look at this one as well. Now it's a problem, so make sure that you have your pens and papers ready and solve it. Light enters from air to glass plate having refractive index as 1.5. Find the speed of light in glass. Assume that the speed of light in air is 3 into 10 to the power of 8 meter per second. Alright, they have not mentioned it, so assume that speed of light in air is 3 into 10 to the power of 8 meter per second itself. Find out what is the speed of light in glass. Options are 2 into 10 to the power of 8 meter per second, 4 into 10 to the power of 8 meter per second, 5.5 into 10 to the power of 8 meter per 11, 10 to the power of 11 meter per second, or 6.25 into 10 to the power of minus 7 meter per second. Alright, this is like, yeah. Sure, Divyaji, today I'll check it out today. No, tomorrow I'll be going to the office. Not today, tomorrow I'll be going to the office. Yeah, tomorrow. So tomorrow's live session will be happening from the office itself, because I have some work in the office. So yeah. Guys, can you read the question? Is it hindering with the question? I mean, should I reduce the size of the camera? Should I reduce the size of the camera before I go further? Can you guys read the question? Are you able to read the options and everything? All good, right? There's no problem with, there's no hindrance, no? Am I covering up the first option? No. Yes, sir. All good, right? All good, no? Okay, yeah. So the answer is 2 into 10 to the power of 8 meter per second itself. Congratulations, people. Congratulations once again. So how do you solve this easy peasy question? Is quite simple. So refractive index of the refractive index. Okay. Refractive index of glass is given. Refractive index of glass is equal to the speed of light in air divided by speed of light. So here the refractive index of glass with respect to air is given. The speed of light in air divided by speed of light in glass is what you have to find out. So it's equal to 1.5 is equal to speed of light in air is equal to 3 into 10 to the power of 8 meter per second, because they have not given the value, so you can assume it as 3 into 10 to the power of 8 meter per second itself. So Vg is equal to 3 into 10 to the power of 8 divided by 1.5. 1.5 is 2, so 2 into 10 to the power of 8 meter per second would be the right answer. Beautiful, guys, beautiful. Moving on to another question. Oh my god, 4 questions, people. 4 questions. What more do you want? All the complaints of Mentimeter is already done. Here is your leaderboard once again, people. Once again, I don't think anyone in the top 10 has got the wrong answer. That is an amazing sight, first of all. But so Yash, not giving up, 8th grader. Moving on to the second position was the first answer. Prasool still on the top, Keshav on the third, Dhruv's on the fourth, Adarsh on the fifth, Harshan on the sixth, Shri on the seventh, MK is on the eighth, Palaji on the ninth, and Tushar, welcome to the leaderboard, on the 10th position. Moving on to the fourth question. So we are halfway through the question. We still have a lot more questions to do, but then that is as we go ahead, we'll be doing it. Here's the fourth question: is if the refractive index of glass slab of thickness 3 mm is 1.5. The refractive index of glass slab of thickness 3 mm is 1.5. Then the time taken by the sunlight to pass through that is how much? They're not asking you the refractive index, they're not asking you the speed of light, nothing. They're asking you how long would it take for the slab. All right, your options: 1.5 into 10 to the power of 11, 10 to the power 11 seconds, 2 into 10 to the power of minus 11 seconds, 1.5 into 10 to the power of minus 11 seconds, or 15 into 10 to the power of minus 11 seconds. Let's go. I know, right? It's a tricky question. What is my height? I'm like 6'9", I believe. No, what? 5'9". No, 6'9". It's 6'9" means I would be playing basketball right now. Oh yeah, I'm 5'9". Sure. Why not, Ashmiji? Come down to Bangalore. Why not? 100%. Do not forget to hit the like button, people. Subscribe to the channel. What is this? Conjusi, people. Conjusi. Alright. 15 of you guys were able to give the right answer. Tell me the truth. How many of you guys are too lazy to solve the question that you guys went with option number 8 just like that? Without even reading the whole question, you guys went with option number 8. Tell me the truth. Like, honest to God, how many of you guys did this? Tell me the truth, people. I want to know that first. This is my sensex. Like, how many of you guys are actually reading the question and how many of you guys just go... Just like that, no? See with okay, that Dhruva, you're like very lucky, no? Ashiji, yeah, always. Alright, anyways, so how do you solve this question? It's actually quite simple. First of all, you're asked to find out what is the time taken. So first of all, find the speed of light in glass. So how do you find out the speed of light in glass? So they've given you the refractive index. So we're going to assume that the light is traveling from air into glass. All right, I'm going to assume that it's traveling from air into glass, or you can assume that it is traveling from vacuum to glass, whichever you feel is comfortable. So the refractive index of glass with respect to air is speed of light in air divided by speed of light in glass. So refractive index is given as 1.5, which is equal to the speed of light in air is 3 into 10 to the power of 8 meter per second divided by Vg. So Vg, that is speed of light in glass, is equal to, just like the previous question, so we found out that the speed of light is 2 into 10 to the power of 8 meter per second. It's the exact same thing. The exact same calculation also we found that. Now to find out what is the time taken. Now anyone who remembers what is the formula for speed? Anyone who remembers? Hi, Kidukachi. Alright, Kidukachi. Tell me now. Anyone who remembers what is the speed wala formula? Anyone who remembers speed formula from your motion chapter? S is equal to d by t. Exactly. Speed is equal to distance by time. Now, they have asked you to find out what is the time taken. They've given you the distance. Distance is given as 3 millimeter. Now here the speed of light is given in terms of meters, so convert this to meters, so this will be 0.003 meters. Alright, 3 mm in terms of meters, 0.003 meters. Now put it down in the equation. So you know the speed of light is 3 into 10 to the power of 8 meter per second, which is equal to 0.003 divided by t. So what is t? T is equal to 0.003 divided by 2 into 10 to the power of 8, which if you divide, you'll get it as 5. What is it? 5 point what? 1.5 into 10 to the power of minus 11. I'm not going to do the calculation because I'll go wrong for sure. So minus 11 seconds would be the answer. That's all right. So you have to just convert. This is the distance. They're asking if you have a glass slab and the thickness of the glass slab is, let's say, okay, I have to draw a 3D figure for this one. So if you have a slightly thick glass slab which is of 0.3 mm, how much time would it take for the light to pass through it? And the time taken is 1.5 into 10 to the power of minus 11 seconds. That's all. Exactly, time is equal to speed of light. That's all. Just use a formula and you will get the answer for this question as well, people. So that is the end of the fourth question. So here is your leaderboard, and then we'll move on to the next topic, and then again we'll come back to Mentimeter. Hold on to that, but we'll finish off the topic first, and then we'll do it in between. All right, so don't worry about it. So that is an amazing looking leaderboard. The shark was in the last position, most of the second place. Congratulations. Prasoon was the fastest to answer. I don't know how. Dhruv's in the third. Yashvi in the fourth. Suyash in the fifth. Keshav on the sixth. Nijam, Adarsh, Harshal, and Shri as well. Congratulations, people. So don't worry, we'll be coming back to the Mentimeter once again. But before we get into that, we have to finish off the topic. And the next topic we're going to talk about is what are the factors affecting refractive index. What are the things that help you decide what is the refractive index of medium? Now there are several factors that affects it. The first one is the nature of the medium. Is the medium like, for example, is it glass or is it water? Because the density of the medium is different, and hence the refractive index will also be different. If the density is different, the refractive index of the medium is also different. So the nature of the medium is the very first factor that refractive index depends on. The second factor it depends on is the temperature of the medium, like how hot or cold if the temperature is more, then obviously the refractive index, because if the temperature is more, the refractive index is also affected by it. So for example, you've probably seen that when the air is hot, this is the simple example that I can think of, like when sunlight falls, the air particles become hot. So that time refractive, like you guys have probably learned about atmospheric refraction. Yes, you understood why you have early sunrise and delayed sunset and all that. You guys remember all of that? So you saw that the refractive index is different at different densities because the density of the air is different. That is one thing, that is the nature. The temperature of the medium also is a factor that it depends on. The third one is the color or the wavelength of light, because like I told you, if the wavelength of light is more, then the refractive index is going to be less, because the light will refract lesser if the refractive index is, if the wavelength is more. So red light will refract the least, whereas violet on the other hand will refract the most, because the speed or the wavelength of violet light is less, so the speed of light will also be less, and so the refractive index is more. Optical density is also one more thing, that is how dense the medium is. Again, it goes back to the nature of the medium itself. So optical density is how dense the medium is, also one more factor that refractive index of a medium depends on. So all of these are the factors that is something that refractive index is dependent on. Alright, now the next thing I'm going to talk about is principle of reversibility. Now, like I told you guys, we're doing the entire chapter, so we have to do all of these in 1 hour time. So I might rush up a little, so please bear with me. The next thing I'm going to talk about is principle of reversibility. What is principle of reversibility? See guys, let's say that a ray of light is passing from first medium to the second medium. And let's say that the first medium is a little rarer. This is a rarer medium, and this is the denser medium. Alright, so you can see that the ray of light is bending towards the north. Now, if I reverse the path, light would follow the exact same path. Basically, no matter, so if the ray of, okay, let's take another example. Imagine that a ray of light is passing like this. This is how the, okay, let's say that it's going from a denser medium to a rarer medium. Okay, let's say that it's going from a denser medium to rarer medium. This is the normal now. All right. Now, if I would, this is the path of light right now. This is the path of light. If I were to reverse the path of light would follow the exact same path itself, because light always travels in a straight line. It's always going to be in a straight line, and hence when there is change in the density of the medium, and there's refraction happening when the path of light changes, it will be in the exact same manner as it happened before. So here also, like I told you, when light, so if let's say that you're standing over here and you're shining light, and you see that the refraction is like this and the ray of light is passing like this. Now if you stand over here at the exact angle of refraction, whatever it is, if you stand there and let's say that you start sending a laser light, it will follow the exact same path, and the ray of light after refraction will follow the exact same same path itself, because this is how light travels. Light always prefers to travel in a straight line. So because it always travels in a straight line, even if you reverse the path, it's always going to be the same itself. And this is what is called as principle of reversibility. So that means that if I want to find out what is the refractive index of the second medium with respect to the first medium, that is sine I by sine r. That is sine. So refractive index of the second medium with respect to the first one is equal to sine I, the angle of the sine of angle of refraction incidence, to the sine of angle of refraction. All right. Now, if I want to find out, because of principle of reversibility, if I want to find out the refractive index of the first medium with respect to the second medium, it will be the reciprocal of this one. It will be the reciprocal of this. So it will be what? Sine r divided by sine I is going to be your, because of principle of reversibility, the refractive index of the first medium to the second medium would actually be sine r by sine I. In other words, what I'm trying to say is this: the refractive index of the second medium with respect to the first medium is equal to 1 by the refractive index of the first medium with respect to the second medium. It's the reciprocal of the same thing. Because of principle of reversibility, you can write it exactly like this. So principle, the refractive index of the first medium with respect to the second medium is equal to the refractive index of the first medium, second medium with respect to the first one. This is what principle of reversibility tells us. So this is how you find out. So if you multiply the refractive index of the second medium with respect to the first one and first medium with respect to the second one, if you put it under the equation, you will get it as this. You'll get it as 1 by 2. Basically, you will get it as 1 because everything gets cancelled out. So you'll get it as 1, which is nothing but 1 by so this is what you're going to get. So once you write it like this, so I gets cancelled because again it's and r sine r also gets cancelled. So what you're left with is 1. So what you get the equation is refractive index of second medium with respect to the first one into the refractive index of the first medium to the second one is equal to 1. So take 1 to the other side, any of these to the other side. So I'll take this is equal to 1 by refractive index of the second medium with respect to the first one. That's all. Yeah, I know, right? That is it, people. That is the end of your refractive index with respect to glass slab. Now let's get into Prism. All right, let's understand a little bit about Prism, because Prism is one of the most important topics in this chapter. There are a lot of derivations from this chapter, so listen up carefully. It's already, I mean, I need a little bit of time, but then I don't know if I'll be able to complete it or not. I'll try my best to complete it. Anyways, Prism. Now, what is a prism? A prism is a transparent medium. It's a transparent object with 5 plane surfaces. You have 1, 2, this is 3, behind is 4 and 5. So you have 5 plane surfaces in a prism. So if you look from the front, if you take the cross section of it, it will be basically a triangle. If you were to cut it in half, it's going to look like a triangle. But this is basically it's like a pyramid. It's not exactly like a pyramid. No, you can't call it as a pyramid. Yeah, you can just call it like it is a refractive surface. Not exactly. You can say that's several triangles kept one after the other. That is what a prism would look like. Now, here you have 2 rectangular surfaces, one at the base is a so basically okay, you can say that this 3 is a rectangular surface and 2 is also a rectangular surface. They both rectangular surfaces which are kept inclined to one another, and then you have a base, and the one that is facing you, this side that is facing you is called as the face of the prism as well. Now, in the case of a prism, the refraction happens through the inclined surfaces. All right, so ray of light is basically incidenting on the inclined surface, not from the front. The ray of light is not incidenting from the front and then coming out of the back. No, the ray of light is incidenting on the inclined surface. So it is basically inclined, right? Those 2 rectangular surfaces which are inclined, that is the one where the ray of light is incidenting. So that is the refracting surface. Now, to talk about refraction through a prism, people, this is what it would look like. So if you have a ray of light, let's say white light passing through a prism, this ray of light is called as an incident ray because it is coming and incidenting on the surface. So because the surface is inclined, this would be the normal, because the surface is already inclined. Normal is what? 90 degrees to the surface, not 90 degrees to anything, but 90 degrees to the surface. So this here would be the normal of the first refracting surface. So if you draw a straight line, this is what it will look like. So I can call it as N1 or something like that. Alright. Now the second one again, so what happens is that because it is traveling from a rarer medium into denser medium, that is air into glass, it will bend towards the normal, and you see that the ray of light will basically pass like this. Now this here, this angle that you see, this is the angle of incidence, right? Because it's the angle formed between the incident ray and the normal, that is the angle of incidence. This here is the angle of refraction, which I can call it as R1. That is the first refraction that happens on the first refracting surface. So what happens? It bends towards the normal and it becomes basically parallel to the base. This is the base. It will become parallel to the base. And again, once it hits the second surface of separation, once again it undergoes refraction. And once again, this time it will go away from the normal. Why? Because it is traveling from a denser medium into a rarer medium. And this ray of light that is passing out of the prism, this is called as the emergent ray. And the angle, so once again, if you draw the normal, this is what the normal would look like, because again, this is the inclined surface, so this would be the normal, 90 degrees, so it will form an angle of 90 degrees over here. So this is forming an angle of 90 degrees. So this angle is called as the emergent angle, which in some books would have written as I dash, or you can also write it as E, which also stands for emergent angle. Whichever way you want to write it, you can write it. If you want to go with I dash, that is also perfectly fine, because again, it's the incident angle. You can say that it's the incident angle for the second surface. For the second refracting surface, this is the incident angle. So that angle is what is called as I dash, or you can say it as E, which is the emergent ray. And this here that you see is the second angle of refraction. Now people, listen up carefully. This is very important. If there was no prism, this ray of light would have basically gone as a straight line, right? Now, if I extend this one, if I were to see from here, the ray of light appears like it's coming from here. This angle that is formed between the incident ray, this is the incident ray and this is the emergent ray. The angle formed between the incident ray and the angle of the emergent ray is called as the angle of deviation. What is it? The angle of deviation, which tells you by how much the ray of light has bent from its original path. Got it? Exactly. That is what is called as angle of deviation, which is represented by the Greek letter delta. This is how this is the whole explanation about your prism. Now, what I'm going to do right now is I'm going to show you the derivation of what is the relationship between the angle of deviation, the angle of prism, and the emergent ray and the incident ray. Now, I don't have enough space to write it out, so I'm going to show you one step at a time. Now, before I get into this, people, I want you guys to remember three things. One is vertically opposite angle. If you have two lines which are basically intersecting each other, this angle will be equal to this angle, and this angle will be equal to this angle. This is the first thing that you have to remember. That is vertically opposite angle. This is one thing you have to remember. The second thing is that the sum of all three sides in a triangle, or the sum of all three angles in a triangle is equal to what, people? Sum of all three angles in a deviation, right? What is the angle of what is the sum of all three angles? What is the sum of the sum of all the angles in a triangle is how much? 180 degrees. Again, this is one more thing I would remember. So angle A plus angle B, angle A plus angle B plus angle C is equal to 180 degrees. This is the second thing I want you to remember. The third thing I want you to remember is, if I have a triangle, and if I have an angle, this is the exterior angle of the triangle. The exterior angle of the triangle is equal to the sum of two opposite interior angle. Now, I want you to remember these three things, all right? So if I call this, for example, here, if I take this triangle, let's say that I take this triangle, all right? If I take this triangle, imagine that I'm taking this triangle, all right? This is the exterior angle, which is nothing but delta. So if I say this is angle, I'll take it as A and B for now. So exterior angle B delta is equal to A plus B. These are the three important things that I want you to remember. One more thing is that the fourth thing I want to remember is the sum of all sides in a quadrilateral. In a quadrilateral, the sum of all sides is equal to 360 degrees. Now, if you know all these properties, which you've already studied in your lower grades. In your math, you've already studied in geometry. What I'm going to show you right now is the derivation to show the relationship between the angle of incidence, the angle of refraction, not the refraction, angle of emergence, the angle of deviation, and the angle of prism. What is the relationship between these four quantities? That is what I'm going to show right now. Now, I want everyone to listen carefully. It's a very, very important derivation. So listen up carefully. Now, again, people, I don't have enough space to write, so I'm going to show you one step at a time. All right. First thing I'm going to do is I am going to use the exterior angle or a property. That is what so first thing I want you to do is consider this angle. Consider this triangle that you see. All right, consider this triangle that you see. So this is nothing but triangle, you can say that MQR or QMR, how you want to put it. So MQR is I'm going to take. This is the triangle I'm going to take. So once again, the exterior angle is equal to the sum of two interior angle. We have just seen like that. So this angle delta is equal to this angle plus this angle. That is what it means. So I'm going to use the different color so you know what. Sorry, this is the angle that I'm taking. This is the exterior angle. So exterior angle is equal to sum of two interior angle. So what I'm trying to say is that QMR, the angle M, is equal to MQR plus MRQ. That is nothing but, this is what I'm going to get. Now what is QMR? It's nothing but delta. So delta is equal to MQR plus MRQ. In other words, angle R plus angle Q. That is what I'm going to get. Now, what is angle MQR? Look at this, guys. Look at this. MQN, this angle. Just take this angle, all right? This one. I'm going to use a different color for this one again. Now, let me use green color, okay? Let me just go back to this one once again. Let me just erase this, guys, so it does not become all messy. I'm going to erase this part, all right? I'm going to show it one more time. Listen carefully, all right? This angle that you see, this angle, in other words, can you tell me, can I say that this angle is equal to this angle? Is it possible for me to say that this angle is equal to the angle inside? Yes or no? In the chat box, is it possible that I can claim that the angle of incidence is equal to MQN? Yes or no, people? In the chat box, absolutely. Why? Opposite, basically, because it's nothing but alternate angle. So it's nothing but alternate, vertically opposite angle. So because of that, I can say that because of vertically opposite angle, I can say that MQN is also equal to I. MQN is nothing but I. Now, again, people, you can do it this way. Now, remember, there are two ways to do it. Either you can do it the way that I'm doing, or you can just directly assume that this angle that you see, you can take it as delta 1, and this angle that you see, you can take it as delta 2. Whichever way your textbooks have told, go according to that. Don't let me be the judge of it, all right? Whichever way you feel is comfortable, you can do it that way. Either you can do it this way, assume that this smaller angle is delta 1 and this smaller angle is delta 2, or you can do it this way and do the same method that I'm doing, but then this will be a little longer. All right? It'll be a little longer. So again, so MQN is nothing but angle I. MQN, that is nothing but this angle. So I'm going to erase this part out once again and do it properly once again. Let me just erase this part. So yeah, I'm going to use red color itself to represent this. So look at this, people. This angle is equal to this angle. So I'll take it as MQN is equal to I. And this, if this is equal to this, I can say this is also equal to this. Obviously, because the same thing. So I can say that MRN is equal to I dash or E. You can take it as emergent angle E, or you can take it as I dash. Whichever way you want, you can go with that. There is no hard bent rule that you have to follow my steps itself. There's nothing like that. Whichever you feel is easier, please follow that. Yes, this will be asked in your exams. This is a clear 3-mark question. It's a clear 3-mark question which has been asked so many times. It has been asked so many times in your board exams. That is why it's so important. That is why I'm telling you one step at a time. Right? So this angle is also equal to this angle. So this is also, again, because of vertically opposite angles, I can say that this angle E is equal, or angle I dash, where they take it as I dash. I don't want to confuse you people, so we'll take it as I dash itself. So I dash is equal to this one, which is nothing but I dash itself. Now, I'm going to assume this triangle right now. All right, I'm going to assume this triangle. If this whole angle is I, what is this angle? I minus R. if the whole angle that you see, this whole angle is I, this smaller angle is what? I minus R, because the lower angle is R, so it will be I minus R. So I'll write that over here. So MQR is equal to I minus R. The same goes to the other side also. If this whole angle is I dash, what is this smaller angle? Smaller angle is I dash minus R. Same thing I've written over here also. Now, what I'm going to do is, because I found out MQR and MRN, I'm going to take this as equation number 1. Alright, they've taken already, okay, they've taken a different value. Alright, so no worries. So what you do is that you substitute these two values in this equation. Substitute MQR value and MRN value over that. So what will you get? You'll get it as I plus I minus R plus I dash minus R dash. Remove the brackets. Take all the I terms to one side. Take all the R terms to one side. So you can write this as what? I minus I dash plus R minus R dash. Now, because both the sides there is minus, I can take the minus sign outside. So I'll get the equation as what? I plus I dash plus, sorry, minus R minus, sorry, plus R dash. This is the equation that I'm going to get. Alright, this is the equation I'm going to get. I'm just taking the minus sign outside. I'm just taking the minus sign outside. I'm grouping all the like terms and grouping all the, removing all the unlike terms and grouping it as like terms. That's all. This is my first equation. Now what I'm going to do is, I am going to assume this quadrilateral. Alright, I will take this quadrilateral right now. Alright, this quadrilateral, that is A, Q, N and R. It's a quadrilateral because it has 4 sides. It's a quadrilateral. Now we already know that the sum of all sides, the sum of all angles in a quadrilateral is equal to 360 degrees. Right? We already know that. Now remember this, people. What is this line that you see? Let me represent that with a different color, maybe yellow. Alright, what is this line? Anyone in the chat box, what is this line? And what is this line? Can anyone tell me what is this line? Anyone in the chat box? What is that line that we drew before? What exactly is that? Anyone who knows it? Exactly, Dhruva. It is the normal. Now, what does normal mean? I'll take it as N and N dash, whatever it is. Alright. What is the normal? Normal is 90 degrees. 90 degrees to the surface. So can I say that this angle and this angle is 90 degrees? Because it's the normal. So can I assume that exactly perpendicular degrees, perpendicular angle, that is nothing perpendicular, it's nothing but 90 degrees. So I can assume that AQN and ARN is equal to 90 degrees. So that means that these two angles are forming an angle of 90 degrees. If those two angles are 90 degrees, because the sum, see, according to the sum of, what is again, in the quadrilateral, the sum of all angles should be equal to 360 degrees. So this means that 90 plus 90 is already taken, alright, plus angle A plus angle N is equal to 360 degrees. Yes or no, people? This angle plus these two angles is equal to 360 degrees. 90 degrees is 180 is already done. 80 plus 90 plus 90 is 180. 180 is already done. So I can say that angle A plus angle N is equal to 180 degrees. Angle A plus angle N is equal to 180 because 90 plus 90 is 180. If I take it to the other side, 180 minus 360 is 180 again. So I'll get as angle A plus angle N is equal to 180 degrees. That is what they have written over here. That is exactly what they have written over here. So they have taken it as QAR, which is nothing but angle A, QNR, which is nothing but angle N, is equal to 180 degrees. What is that? What is QAR, which is nothing but angle A? So in place of this one, in place of this, I'm just substituting A in place over here. They have done it indirectly over here. I'm just writing it directly. That's all. All I'm doing is I'm writing it directly. There is no difference. It's the exact same thing. I'm just writing it directly. That's all. There's no other difference. So I'll get it as what? QNR is equal to 180 minus A. Because what? I'm writing, in other words, I'm writing angle N is equal to 180 degrees minus angle A. That's what I'm getting. That is what I've written over here as well. This is my second equation. This is my second equation. Now, what is this A? Now, take the triangle, guys. Take the triangle. What I'm going to do is QNR. This angle that you see is 180. Okay, what I'm going to do is, instead of say angle A that you have, all right, this angle A, what I'm going to do is I'm going to substitute this value over, one second guys, one second. I think I made the mistake somewhere. No, wait, one second guys, one second. So I found, is it clear till here? Till here, is it clear, people? One second guys, one second. I think I made a mistake now. Q and R, Q and R. Oh yeah, all right. All right, yes guys, yes, yeah, that is right. I did not know that. Once again. Let me just erase this. Let me make it clear. That is why I got confused. Once again. All right, now what I'm going to do is, I am going to assume this triangle. I'm going to assume this lower triangle. Now, what is angle N? What is angle N in this angle? Again, what is this? Angle N plus R dash is equal to 180 degrees. Because again, the sum of all the angles in a triangle should give you 180 degrees. So angle N plus R dash, because this is R dash, which is equal to 180 degrees. So if I rearrange the equation to get N, so N will be what? Angle N is equal to 180 degrees minus of R plus R dash. They have just taken, they just, they've taken it into a bracket. So you'll get this, you got this angle, what is that? Angle N is equal to 180 degrees minus R plus R dash. This is your third equation. Alright, so you found out that A is nothing but R plus R dash. Now, it is, see, what you're doing is you're equating the, so what you just do this. Equate the second and the third equation. If you equate the second and third equation, you will get that angle A is nothing but R plus R dash. Now what I'm going to do is I am going to substitute that in the first equation. The first equation that I got, which is nothing but delta is equal to I plus I dash minus R plus R dash. I know that R plus R dash is A. That is what I got over here. That is what I found out. So in place of R plus R dash, I'll just substitute A. So what will I get? Delta is equal to I plus I dash minus A. Take A to the other side. So delta plus A is equal to I plus I dash. That's all. Did you understand this, people? Did you understand what I just taught you? Is it clear? Again, I don't have enough time to go through everything. We've already spent, the session is already done, but I still haven't completed the topic. So yeah, let me try to finish off. Is it clear, people? Did you understand how I got it? Such a simple derivation, but then yes, it requires a little bit of calculation and a little bit of understanding. So first thing, once again, I'll tell you guys, first thing, I'll tell you one step at a time, alright? First thing, what I assumed was that I took this triangle. First thing, I assumed this triangle. Then I took the quadrilateral. Alright. Then what I did was that first thing I assumed this triangle. Then I assumed the quadrilateral. Once I assumed the quadrilateral, then I took this triangle, the lower triangle. I found out what are the angles and got this particular value. I'm going to erase this one because you can download the notes later and refer to it if you want to. Now yes, people, in some books, instead of taking it as I dash, you will take it as E. Again, it's the same thing. Emergent angle I dash, it's nothing but the emergent angle. Here they're taken as angle of incidence. So the angle of incidence, the second one, it's the same thing. So this is the relationship between angle of refraction, angle of incidence, the emergent angle, the angle of the prism, and the angle of deviation. That's all. Right? One of the most important formulas that you have to remember, and one of the most important derivation as well. All right? Okay, now here's another one. Factors affecting angle of deviation. Guys, I don't think this one also I'll be able to complete now because there's a lot to do. I don't think I'll be able to complete this. So wherever we can, we'll just stop it right there. And in the next session, again, I'll do the second part for this one. I'll come for live, that also I'll come live, and I'll finish off the rest of it. All right. I'm blocking the screen once again. Let me just see if I can. Maybe next session I'll take more care into it. I'll reduce a little, reduce the screen size a little. All right. So yeah, people, I don't think I'll be able to complete this. I'll not be able to complete this. So I'll try to do as much as I can, but I think we'll stop it right here after factors affecting of angle of deviation. We'll stop it right here now. The rest of it, that is total internal reflection and all of that, we'll do it in the next one. All right, because there's no point. I can't complete the whole topic. It's too long. It's way too long. All right, factors affecting angle of deviation. Now, the first factor is this, guys. Angle of deviation is affected by the angle of incidence. So, people, here's the thing. This is one of It's a very important topic. Very important topic. Has been asked several times. Has been asked several times in the exam. So listen very carefully. What is the dependence of angle of deviation with respect to angle of incidence? Now there's a graph. This is called as the angle of incidence and angle of deviation curve. This graph, according to scientists, from what all experiments we have done, it is very clear that if I decrease, so if as I increase the angle of incidence, so angle of incidence is I, which is at the x-axis, and angle of deviation is nothing but your y-axis, so angle of incidence and angle of deviation. This is what I have. Now, if I increase the angle of incidence, if I were to increase the angle of incidence, the angle of deviation will start to reduce. What is it? If I increase the angle of incidence, the angle of deviation will start to reduce. Now again, this reduction is not linear. In other words, it's not directly proportional. So for example, if I give you an example, if angle of incidence increases by 10 degrees, it does not mean that angle of deviation will also decrease by 10 degrees. Alright? It does not mean like that. That means the curve will look like this. It's not a straight line, it's a curve. That means it's not exactly proportional. It is not proportional. It doesn't work like that. If I increase the angle of incidence, the angle of deviation will start to decrease. But at one particular time, at one particular angle of incidence, once it reaches that minimum value, so this the lowest value that you get is called as the minimum angle of deviation. We can write, which you can write as delta m, which is nothing but the minimum angle of deviation. Once it reaches that value, if I continue to increase the angle of incidence, rather than decreasing it, the angle of deviation will start to increase suddenly. So once again guys, listen to me very carefully. When the angle of incidence increases, in the start, the angle of deviation will also decrease. It will go down, the curve will go down. But at a certain point, what will happen is that once it reaches the minimum angle of deviation, if I keep on increasing the angle of incidence, the angle of deviation, rather than decreasing, it will increase suddenly, and that is what forms this curve, which looks like this U-shaped curve. So as you increase the angle of incidence, at one point it will stop decreasing, the angle of deviation will stop decreasing, and then it will start to increase. So in other words, what I'm trying to say is this: the angle of deviation will become minimum. The angle of deviation will become minimum when angle of incidence is almost equal to angle of emergence. When angle of incidence and the angle of emergence is almost equal, at that point of time the angle of deviation is going to be bare minimum. Now again, how did we get this equation? Remember guys, delta plus A is equal to I plus I dash. So if angle of incidence and angle of deviation, angle of emergence is pretty much the same, so in place of I dash I can write it as I. So I'll get it as delta plus A is equal to I plus I, which is nothing but 2I. So I can write it as delta is equal to 2I minus A. This is the formula to find out the angle of minimum deviation. Got it, people? Is it clear? That this is one of the property. This is how it happens in a prism. So once you reach the certain limit, this is the same with what to say. It's the same, like you can see this phenomenon in water also. For example, if you keep on decreasing the water at a certain temperature, the water will not turn into I think it was around 4 degrees or minus 4 degrees. I forgot what is the name of it. I completely forgot about it. But yeah, at a certain temperature, you can see that water will not absorb, or basically it will not turn into ice, but rather it will start to increase the temperature or something like that. I completely forgot, but it's a common phenomenon that you see in in nature. Like after you reach a certain limit, it's the same with semiconductors also. Okay, I can give you another example of semiconductor. That is better. So in semiconductors, what is the problem of semiconductors? It will behave like an insulator until a certain amount of current is passing through it. Once you increase a certain amount of current, then it will behave like a conductor. Everyone knows about semiconductors, right? You have this in your exam, you have it in your science, right? Semiconductors. So it's exactly like this. So what happens is that once you reach that certain limit, once you increase that certain limit, once you go beyond that current limit that is there, it will start to behave like a conductor. It's the exact same thing over here also. Once it reaches the minimum angle of deviation, then you keep on increasing the angle of incidence, it will keep on increasing rather than decreasing. That's all. Yeah. Yeah, that's it. Yeah, I know. Oh, yeah, I know. Anonymous behavior. Yeah, I know. I know. Anonymous. Alright, I forgot the name. I read it very long ago, but yeah, I still remember a part of it. So yeah. Anyways, so that is the first factor. The second factor that angle of deviation depends on is the prism itself. That is the type of material that you have. So you see this, guys. The type of material matters. Like if you talk about flint glass or crown glass, again, depending on the material, the angle of deviation would also be different. So if the density of the medium is more, then the angle of deviation is going to be more. If the density of the medium is less, then the angle of deviation is going to be less. In other words, if the density is more, then we'll have higher refractive index. So that means greater deviation. Lesser refractive index would be lesser deviation. This is one more factor that it depends on. The third factor it depends on is the angle of prism also. Greater the angle of prism, the greater would be the deviation. So if you have a prism of 60-degree angle, the angle of deviation will be somewhat higher. But if you have a prism which has angle of, the angle of prism is 90 degrees, in that the angle of deviation would also be much more greater. So it depends on that factor also. And finally, guys, it also depends on the wavelength of light. So greater the wavelength of light, the lesser the deviation. Lesser the wavelength of light, greater would be the deviation. Right? So that's it, people. That's it. And yes, let's do the quiz. Let's do the quiz. We'll finish off with this one quiz time. And yeah, because I don't have time, let's just stop it right here. The rest of it, we'll do it as one shot part 2. So wait for that as well. So the work power energy part 2 also will come out this week, and this light also part 2 will come out this week. All right. Yeah, people, that's all. Exhausted. All right. The fifth question, people. I think this is the last question because the rest of it we have not done it. So here's the last one. The angle between the two plane refracting surfaces of a prism is called what? The angle between the two plane refractive surfaces of a prism is called as what? Angle of incidence, angle of refraction, angle of prism, or angle of deviation. Come on, guys. Let's go. Let's go. I know, now because I'm talking fast because there is so much more for me to do, but I don't have time to do it. That is why. That is why I had to talk fast so that I can complete it off in 1 hour. But then that also did not work because in another 4 minutes I have another session. At 6 o'clock I have another session, so I have to go for that. Otherwise, I could have extended this, but not possible. If I had time, I would have extended for another 20 more minutes, but I can't. I've extended for 15 minutes, but I can't do it any more than that because I have another session right after this. Anyways, the right answer, people, is angle of prism itself. That is basically the two refracting surfaces. That's nothing but this one. So those two, the angle formed between the two refracting surfaces is nothing but the angle of prism. And this, my friends, is the final leaderboard for the day as well. I mean, the rest of it, don't worry. The rest of the questions we'll do it in the next session, so don't worry about it. Pakka will do it. It's my promise, my word is my bond. So don't worry, next session we'll have it. I'll try to come live itself for that one as well, and let's finish it off. Alright, so this is it, people. Prasoon Ji is the winner for today, followed by Tushar, followed by Dhruva or Dhruvs, Yashvi, Suyash, the fastest to answer the last question, Dijam to answer the question the fastest, and Keshav, then MKS, Kritika, and Parley Ji as well. G for genius. Yeah, I will speak slowly because the thing is that, guys, it's because I have so much more to do now. The reason is that I have so much more to do. If I just skip this part out, there is so much more to do. We have to talk about real apparent depth. We have to talk about, this is one more derivation that we have to do, the proof for the real and apparent depth. We have to do that also. Shift, we have to talk about that. Total internal reflection, critical angle, total internal reflection in prism. There is so much more to do, but we don't have time to do it. So these topics that we have not completed today, I'll be doing it in the next session. I'll come out live once again for that one as well, people. So we'll see there. All right? Yeah. Got it? Yeah, yes, exactly. It'll be 2 shot, not 1 shot. It'll be 2 tukda, 2 shot, 3 tukda. It'll be like that. That's all. That's it, people. That's it from my side. Thank you for joining. I hope you guys learned something new. I know I was going a little fast. It was only because of this so that I can complete the whole thing in 1 hour duration, which I utterly, beautifully and stupidly failed. But still, I hope that you guys were able to understand how much ever I taught. So I'll see you guys in the next one. Take care of yourself. Yeah, but people, do not forget to hit the like button. Do not forget to subscribe to the channel. Subscribe to the channel so that you are able to, get notified of the future sessions as well, which will be, light session 2 as well. So I'll see you then. Bye everyone. Take care of yourself. Thank you for staying until the end. I really love you all. See you guys. Thank you for all the support. Thank you for all the love that you guys are showing us. Keep supporting us. Keep showing the same love. I'll catch you guys in the next one, guys. Bye for now. Take care. Thank you, Bhargaviji. Bye Alina, bye Ashmiji, bye others. Take care. See you all in the next one. Next session we'll be doing real and apparent depth and TIR and whatever is left out. So until the next time, goodbye. And yes, people, do not forget about this thing, the leaderboard. I'll be putting it up in the shorts as well, the YouTube shorts. So look out for that. All right. Bye guys. Take care. See you all. Bye. Thank you guys. Bye. See you all.